All right, guys. So welcome back to my fantastic chemistry podcast. How you guys doing so far? Hi. So Tusky is right here. Me and Tusky are doing great, right? To be honest, I never thought of making a podcast before, right? But but kind of situation kind of forced me to because of the COVID, right? Recently, and everything went online, and it kind of came up with an idea how to make chemistry a little bit more fun and entertaining than normal. And I thought, well, podcast can make anything look fancy. Why not make a podcast? That's how we got this podcast going. Okay. Again, if you like it, don't forget to click like, subscribe, or rate 5 star. Leave a comment. Do whatever you want. Tell your friends. Tell your family. All right. So we're doing great. We're fabulous. Here we go. All right, now we have finished chapter 1 and 2. Okay, now we're gonna go on to chapter 3. Let's see, come on, go right there. Okay, so chapter 3 is gonna be about acids and bases. Okay, at the beginning gonna be again like review from Gen Chem 2. I think you learned it in Gen Chem 2, and the rest gonna be something new. Apply from what you know from Gen Chem 2 to new stuff. All right. Okay, let's get started right here. In the old time, long time back there, when Snapchat was not invented yet, okay, people recognized acids and bases by their property, right? They don't know what they are exactly, but they are recognized by their property. For example, an acid. Have you tasted lime, right? Sour taste, right? Vinegar, a little bit wine, right? Wine is a little acidic, so that's acids have sour taste. In contrast to an acid, bases have bitter taste. Okay, not sure have you tasted salt before. I hope not. Right? Toothpaste, maybe some of you have tasted, but most of us have tasted before, so it's kind of bitter. Right? So not that appetizing. Anyway, acid and bases can change colors of some dyes. For example, litmus paper. Okay, and if you put them together, acid and bases, they cancel effect of each other out. We call it neutralization. You learn that in Gen Chem 2. Okay, and but no one didn't really know what an acid and bases were back then until we got these two scientists. So you see, in 1923, we have a guy from Johannes Nicholas Bronsted from Denmark, a chemist. Okay, and we have Thomas Martin Lowry. This is from United Kingdom. I think he's from London, right? And they independently point out that acid and bases can be viewed as a proton transfer reaction. I'll take a look right here. Right. So if you still remember, I just remind you real quick. So hydrogen, with a positive charge, we call a proton. If you remember, hydrogen have one proton, one electron. Losing that electron, it's just a proton, like H plus, right? So we call it proton. Okay. So acid and bases reaction can be viewed as a proton transfer from an acid to a base. All right, look at right here. Look at this proton right here. Water in this case will act as an acid, right? Transfer proton to a base. So base is third butoxide. This guy's name is third butoxide. We'll talk about the name later, right? So base is a proton acceptor. Acid is a proton donor, and water after have donated a proton become hydroxide ion. We call in this particular situation we call a hydroxide ion as a conjugate base of water. So acid become a base. Right, conjugate from in Latin mean together or attached. They come together. Every acid have a conjugate base, and every base have a conjugate acid. Third butoxide become third butanol. Right here, this is an alcohol, third butanol. Okay, all right. Let's try. By the way, so basically, acid-base reaction is like playing catch from acid to a base, and the proton is just the baseball. Okay. All right, what we got right down here. So can you guess who's an acid and who's a base? Of course, you can see the proton right here. This is hydrochloric acid. That's one of the strongest acid that you know. Okay, so that's an acid. Ammonia, NH3, that's a base, right? Now, who's the conjugate acid and conjugate base? They are right here. They are together right here. I'm going to split them up. Can you see this is NH4 and Cl? This is ionic bond. Right, so NH4 plus right here, that's the conjugate acid of ammonia, and chloride is the conjugate base of hydrochloric acid. Okay, so hydrochloric acid become a base become an acid. Okay. All right. I want you to be kind of cool to look at it. If you look at this reaction, this is in gas phase. See that? An acid-base reaction doesn't have to be in a solution. It could be in a gas phase as well. Take a look right here. So hydrochloric acid solution down here is really concentrated, so they vaporize, become hydrochloric acid gas. Ammonia, that's the same thing. Ammonia become gas right here, but they both are colorless. Colorless. You can't see them. But when they become once these two come into contact, they react to each other. They form an acid-base reaction and form ammonium chloride, which is solid at room temperature. You see the white gas light right here. That's actually not a gas. That's a solid ammonium chloride. That's formed. Okay. All right. Okay. That's a definition of acid and bases and conjugate acid and conjugate base. All right. Let's moving on to the next video.